This video is going to be going over the second part of the lesson, which is to convert rectangular coordinates to polar coordinates, or Cartesian coordinates, or xy, to polar coordinates. So we're going to go back to this diagram where you have a point and it's described by the ordered pair xy, but now we want to be able to express polar coordinates in terms of x and y. So we're trying to find out what r is equal to and what theta is equal to this time. So we're going to use what we know again with trigonometry. We know that we can drop this down and we have a right triangle where this base is x and the height here is y, and we're given r, which is the hypotenuse of this right triangle. So this is a typical kind of problem that we would look at if we were trying to find out the length of a hypotenuse if we're given the legs of this right triangle. That's using the Pythagorean theorem, a squared plus b squared equals c squared. But in this case here, we're going to use x squared plus y squared equals r squared. Now we're really close to getting r by itself. We have r squared. So I'm just going to rewrite this just so we can keep track of having r on the left side. And we want to get r by itself by taking the square root on both sides of the equation. Now, yes, we would have a positive and negative solution to that when we take the square root on both sides, but also just keep in mind, once we have r by itself here, let's think about what r stands for. It's the radius, which is the length, and length cannot be negative, it's going to be a positive. So we're just going to have a positive square root of x squared plus y squared. I'm going to put that over here. So we have that as one of our formulas. Okay, now we need to find out what theta would be in terms of x and y. So if we're dealing with an angle measure and we have this right triangle, we are going to be using our basic trig ratios to help us find out how we can get theta by itself. So SOHCAHTOA means that we have the ratios sine of theta equals, again, y over r, or opposite over hypotenuse. Cosine of theta is x over r. Tangent of theta is y over x. So which of these equations are going to give us information about theta in terms of x and y? For sine and cosine, they do have theta, they do have y, or they do have x, but we have r here and we don't want to have that. So tangent is going to help us to get theta by itself in terms of y, x and y. So how can we get that theta by itself? Really the only thing in the way is tangent, and we can get rid of that tangent by undoing it, and that's going to be the inverse of tangent. So we're going to take inverse tangent on both sides. So I'm going to have inverse tangent over here, and I'm also going to take inverse tangent over here. So that undoes tangent, and all I'm left on the left side is theta. So I have theta is equal to arctangent of y over x. So that's going to be my formulas for converting from rectangular coordinates to polar coordinates. Okay, I am going to refer back to that with doing a couple of examples. We're going to just look at one example together, and then you'll be able to practice some more with the assignment. So we're going to convert -12, -9 to polar coordinates. So that's our x and y. And I'm going to bring back again that formula that we put together. So it was r equals square root x squared plus y squared. Theta is arctangent of y over x. Now, for finding the radius, we can substitute the x and y into that formula. So it's the square root of -12, close parentheses, squared, plus -9, close parentheses, squared. So since the negative values are, the negative sign is inside of the parentheses there, when you square, you do end up with a positive number there, positive value. So you have 144 plus 81. That's going to make 225 in the square root, and the square root of 225 is a perfect square. R is going to be equal to 15. Okay. The next part over here, I'm going to actually put all the work on the right margin here for theta. So we're going to find out what theta is by using arctangent of -9 over -12. I can go ahead and simplify that, that's fine, or I can go right to the calculator and just make sure to input that exactly as it is in there. So on a graphing calculator, or you can just use Desmos, just make sure that you are putting this in degrees. So if you needed to make sure to go into that mode, that's going to be second function, that's to quit. You need to just go to mode here, and then you can change it to degrees. So I'm going to calculate arctangent by doing second function, then go to the tangent key here. I put in parentheses -9 and use the negative sign over here, negative key. Divide that by -12. Close parentheses there. And I have the degrees, let's put it to the nearest tenth. That's 36.9 degrees here. So I'm going to keep that in mind. And actually, we are not done with that. The reason is because we have to think about where exactly -12, -9 is located on the xy plane. So -12, -9 is in the third quadrant over here. It doesn't have to be exact, but it's going to be in quadrant 3. So with it being in quadrant 3, we are basically going to have this ray here, and the angle is going to be the reference angle that we have. So this reference angle, and that's very small, but that's where we have theta is equal to 36.9 degrees. We want to find out what the angle is from 0 degrees. Okay. So that means that we're going to need to take that angle for in reference to quadrant 3. So that means we have to add on another 180 degrees. So let's add 180 degrees to this. That is going to be, we have 216 degrees and 9/10. So approximately 216.9 degrees for that. My final answer then is -12, -9 is converted to 15, 216.9 degrees. Okay, so use these formulas, and then you can use this example to help you out with these problems with converting rectangular coordinates to polar coordinates.